Hello, everyone, and welcome to today's virtual Eclipse community meetup. My name is Irina, and joining us today is Sven Trittler, who will be presenting CycloneDDS Insight, bringing DDS debugging to Eclipse IoT. If you have any questions for Sven as we move through today's presentation, feel free to ask it in the chat or use the Ask the Question tab. Without any further delay, Sven, over to you.
Yeah, thank you for having me, and I'm gonna share my screen. Yeah, so here we go. Yeah, so my name is Sven. I'm a software engineer from Germany, and yeah, today I'm gonna introduce a new tool to the Eclipse IoT community I just developed in the last year. Yeah, so it's called Eclipse Insight, and it's all about debugging DDS and visualizing DDS. And I would say we jump right into it. So what's on the agenda? I'm going to do a little DDS in a nutshell and its use cases. So it's just going to be very quick so that everyone is on the same term. And yeah, after that, I'm going to present the problem I'm trying to solve. So why the debugging DDS is hard. And yeah, then of course the solution, the tool. And I'm going to show you some key features and the technology stack. And yeah, then some timeline and roadmap. So we're gonna looking back and looking in the future. And yeah, then probably the most interesting part is the live demo at the end. So stay tuned for that. I prepared a little robot setup, and we're trying to solve some bugs there with the tool. And yeah, at the very end, we're doing the Q&A session. So yeah, feel free to ask questions at any time. Yeah, so let's start with DDS in a nutshell. So what is DDS? DDS is a data-centric messaging framework. Basically, apps can read and write data, or how we call it, samples, from to a topic. Then there are quality of services. They define the availability of data. And last but not least, there is this dynamic discovery, which isolates app from the network topology and the connection details. So you don't have to care about IP addresses and all that stuff. So it's just about the data and what's the state of the data. So that's why it's data-centric. Yeah, so when we look on the right-hand side, there are basically the 5 terms you need to know about DDS. There is the data writer, basically producing data, and he presents that data to the topic. So it's called topic B here, but it could have a name like topic navigation, providing latitude, longitude, or something like that. Then there are data readers. And data readers, they receive the data from the topic, and everything happens inside this domain. So a domain is basically a tool to separate or isolate different subsystems. Yeah, you can do some architecture with it, and yeah. Then there is this little QoS icon on every entity. And this, as I said, defines the quality of service. So for example, you could say, okay, this data from that data writer, I'm going to publish it every few seconds. So I don't need to care about if it's reliable or not. Data could be lost. That would be fine for that topic. Then there are other topics, like you press a button and you want to happen something, then you may want to have the data reliable. And then you would set the quality of service to reliable so that the DDS framework would retransmit it until it's delivered to the data reader. Then there is one other quality of service, like when your data reader joins the network later. So the data writer starts up and publishes some state, and the data reader joins later. Then you can also define a quality of service saying, hey, the data should be received by the reader at any time, even when he joins later. So That's basically the most important one. Then there is one other, this filter icon here. So you can say in a domain on a topic, you can define partitions. So you can separate the data a little bit more. But yeah, I think that's all you need to know for the presentation about this tool. Then we jump to the use cases. Where is DDS used? It's used in the Internet of Things world, the IoT world. And yeah, it's used in air traffic control, in cars, in what do we have here? In wind turbine parks, basically everywhere where sensors come together and want to build something amazing. And many more, of course. So what's the problem? What problem do I have and I wanted to solve? So when coming to DDS, there are lots of moving parts. So there are dozens of domains and topics and endpoints. And like in a real system, at some point you lose control of it. And yeah, when you look on the right-hand side, this is a Wireshark trace. So this is a tool to look into the network traffic. And this is just a network traffic from a simple message I send every second. So you can see there's lots of things going on. You've basically no idea when you're not an expert in RTPS. And yeah, it's not like your usual HTTP request, and you would have like one line and you could be able to copy the body from that line. Yeah, in DDS, the data is serialized and you cannot read it that easy from Wireshark. So Wireshark is in DDS world more a tool for like really experts or DDS developers with some crazy like Wireshark filters. But like for the normal user or for the normal companies, it's just too much. So there are no clear answers to critical questions. So is the system healthy? Are there any retransmits? So basically, did I messed up some switch configs, or do I have a faulty cable or like whatever? And are there any quality of service mismatches? So as I mentioned in the introduction, the quality of service, they have to match. So otherwise we don't receive data. And yeah, then when you build systems with DDS, systems often tend to have no documentation or the documentation is outdated. I know it should not be like this, but kind of that's the real world. So they should deal with it. And then you wonder what's the actual runtime architecture, so what's really running in your system. CycloneDDS has a command line tool. You can see it on the bottom here. But you can see it works for your Hello World application, but when you have a system with, let's say, 200 participants and 50 domains and even more endpoints, you would have like 10 pages of terminal text, and that's not how humans can work good. There is also a saying in Germany, which is a picture tells more than 1,000 words. So we need somehow have a visual navigation through all the DDS data. And yeah, so am I the first person on Earth writing a graphical application for DDS? No, of course not. But there are no free and open source tools to meet the needs of real-world DDS systems. So there are a few. There are Vortex Insight, SETA C2, RTI Admin Console. But they're all commercial. So yeah, it's not really suitable for the Eclipse IoT because we believe in open source and not this closed source tools. Then there is FastDDS Monitor. It's open source and I try to use it. It also has some statistics and health informations, but I was not able to send and receive data, and so it lacks lots of features you really need in a real-world application. So the last point here is difficult accessibility to DDS. So when you first start with DDS, it can be hard to get into it and running all the examples. I mean, it's gotten better with all the Python wrappers and stuff, but for example, in C++, then you have to check out the C repository, then you have to compile it, you have to figure out the dependencies, and then you have to build a C++ wrapper and try to create some EDL files and compile it. So it's not like you download a browser, you open the browser, and you go. It's not like in 10 minutes you sit there a few hours to get everything work. So I wanted to have a tool which I just can use like a browser, download, open, and go for it. So there is the solution, of course, the one it's about today. So I created Eclipse Cyclone DDS Insight. So it shall provide insights to DDS. So that's why it's called Insight. Maybe not the most creative name, but should be fine. So it's a graphical tool to visualize and debug DDS systems. You can see a screenshot on the right side here. And yeah, so some key features are like visualize the DDS system. You can see, for example, here the topics on the left side. You can send and receive DDS messages. So just in front of you, you have these tabs, and then if you have listener, tester, statistics, details. So system health is also going to be addressed, detecting retransmits and QS mismatches. And one point I thought would not be that important, but figured out it's more important than I thought. It's the learn about DDS point. So I integrated a shapes demo. So this is a well-known demo in DDS world to use DDS and check out quality of services and get your hands on. So it's also included in the application. And yeah, last but not least, probably the most important part, it's free and open source. Everyone can download it, can participate, can fix bugs, can create bug reports, do everything. Yeah, because we are with closed source and all the licenses, it's to manage the licenses, it's a hassle. So you don't want it even in a professional environment. So the whole world is running on open source, and so that way we want to continue. Yeah, on the next slides, I'm going to the key features of the tool. Of course, there is more to it, but I'm just going to present like the most important one. So we start with the overview. So as you saw on the screen before, you can see on the left side, you can see the topics. So you have basically all the domains listed. And then you see the topics. You can, with that plus here, you can add domains, or you can even automatically discover domains. So when you like kind of reverse engineer a system, that's pretty helpful. Then you can click on a topic here, and then you see all the writers and readers I mentioned on the right-hand side. So on this page, we can see 7 writers, and they're writing each to a different partition. So there is some flight data from Sweden, from Italy. Yeah. And we have one reader here, and this reader is only listening to the traffic from Italy. So that's what was about that content filtering and partitioning. And so with the tool, you can easily see what's going on and click on this partition here, and then you see, okay, that reader matched with that writer, and then the data will flow between those two. Then you have a little burger menu on the top right. So you can go for checking for updates, settings, and all of this less important stuff. And then you have a little data model on the bottom left side. So you can drag and drop your IDL files just into it and directly read and write data from it. So let's go to the next slide. I just switched over to the participant view. So that's here on the top. You can switch between topic and participant view. And yeah, that view is for a kind of a different purpose. So in the topic view, you are more focused on your business logic. So you just care about the data and what state the data has. And then in this participant view, you can see all participants. So here you can see there is a host, Sven's MacBook, and it has 3 processes running DDS with the process ID. And then you can open it and then see which DDS participants they have and which topics. And when you would open that one further, then you would see also the readers and writers that process opened. So in this participant view, you are more focused on works everything well from like a DDS perspective. So you want to see, hey, does all the applications have their readers and writers, and are there hosts missing or something like this? And in the other view, like I mentioned, you focused like on the data and you want to get your business logic done. So on the next slide, I'm gonna present you how to sniff into the data you sent. So maybe it's good to know that there is a topic, flight data, but what data is there? So you can look into it by, let's just go one back. Here in the top right side, you have this create reader. So you can subscribe to that topic without even the need of having an IDL file. And for legacy systems, you can import the IDL file. So depends on which system you are. You could just create the reader when the type information is in the network, or you just go with your IDL file. So when you create that listener with that button, then you can go to the listener tab here, and then you see all the data going through that topic. And yeah, that's pretty nice feature, because sometimes when you're in a system, you don't have access to all the participants, because sometimes, you know, different companies doing different subsystems, you don't have access, you can't see log files. So you can just sneeze in and check what data is there, and yeah, is that data expected or is there any wrong data? So here we can see like flight ID 0 to 10 with different positions and regions. And yeah, so now we want to do the opposite. So what's about, I already mentioned there may be more teams involved, and maybe one team is faster than the other, and you want to, yeah, you implement your interface and someone should send you data. But that someone is not there yet, but you still want to test in the lab, because of course you have unit tests and stuff, but the real magic happens in the lab, and the lab is the only truth. So we have the tester. So you can also use, for example, the data model, and you right click on it, create a writer. And then you have in the tester tab, you have all your writers. In that drop-down menu, you can then select your tester. And in this case, I created it for the flight data. So the flight data shows up here, and I can enter my values I want to send. So in this case, the writer is not available in my system to send me this data, so I just mock it up with that tool. And yeah, so I enter the values, some ID, some position, some region, and then I click write. And then I would see the data in my listener, and my application would receive it. So that's very powerful. And I think that was missing on a lot of tools, even the commercial tools. So I had access to some commercial tools, and I always does not felt that intuitive. So I implemented it straightforward. You create a writer, click on tester and write the data with no further configuration. So listening and sending data was, I kind of played a trick on you. So before you create a reader or writer, you have to select the quality of service in every step when you create a reader and writer. So every time you create one, you will end up in the quality of service selection. So you can see the scroll bar is quite tiny here, so there are lots of QoS. But as I mentioned in the introduction, you basically need, let's say, 3 or 4 QoS settings. So when we want to create a reader here to listen into data, we can say, the reliable should be best effort, durability volatile, and you can do it for reader QoS, subscriber, and topic QoS. So it's not sorted alphabetically, because I think there are these 3 or 4 most important quality of service. I just put them right in front of you, so you don't have to scroll a lot to access like the most common quality of services. And as I implemented it, I also learned a lot of things about DDS and what quality of service they are. So that's also a great learning platform. As I mentioned, is also one goal. Because sometimes it's hard to figure out what quality of services they are, and because you end up on some documentation websites, and here it is compressed in a few clicks away. Okay, then we go to the next feature. So we're addressing now the system's health. So are there any quality of service mismatches? And in this picture, you can see you opened Cyclone Insight and your domain you're working on, and then you see this warning triangle here. And then you open the domain and then you see it on the topic. And then you might wonder, okay, something is wrong here. You click on a topic, and then you see on a topic also a slightly bigger warning. And then there is a orange yellow rectangle around the readers and writers, which are detected to have a mismatch. So in this case, we can see, okay, all the writers, they have a mismatch with that reader. So either all the writers are wrong or just that reader is just completely wrong. And then you can hover over that reader or writer, or you click on it, and then you can put like these 2 windows side by side, and then you can see, oh, okay, that reader has some durability issues. The qualities, durability QoS seems to be different than like to these writers. And then you put 2 windows side by side, and then you compare them, and then you quickly see, okay, there's a different setting. So that's gonna explain why maybe data is not flowing. And like I mentioned with the partitions, so here we clicked on the Italy partition, and we also see only the first one is green. So there are no partitions. So that's also an indicator that the data would not flow. Coming to the next slide, also addressing the system's health. So we want to know, hey, is my network in good condition? So are there retransmits? Do I have faulty connections or something like this? Then, okay, there's one note to the statistics. It's only available for CycloneDDS, which has enabled the monitor port. But yeah, and on this topic, there's no standardization yet, I guess. But when I figure out how to get statistics from other vendors, I will try to add them here. And yeah, so you click on it and you can see on your domain which topics are there, for example. So the most important part basically is this aggregate drop down here. So you can choose between choose the aggregation between hosts, processes, domains, readers, writers, and topics. So we can see here the topic view. So we can see here there are some topics, and this orange has some retransmits. So in this case, the retransmit are because of the discovery phase at the beginning. So some data is lost there and it's retransmitted. And yeah, in this first diagram, you see how many bytes are retransmitted. And in the second, you see the counter, how many times it was requested. So on the DCPS subscription topic, there were 114 retransmit requests. And that was like 41,000 bytes. And there's some more when you scroll down. And I think the most important thing is, like I mentioned, the aggregate by, because when you're in a big system, then you probably have lots of domains. So just maybe start with the domain, and then you see, hey, on that domain, there are lots of retransmits. And maybe on that domain, there are lots of embedded boards or something. So then you go deeper, then you go to the process, which process is having lots of retransmits. So you work your way down to try to find the error, or at least an indication for it. Okay, so then the next feature is a quite simple feature, to be honest. So there's a configuration editor. So in CycloneDDS, your configuration is in a XML file, and then you put on an environment variable, CycloneDDS URI, with the path to that file. And it seems to be a small feature, but to be honest, it saved me a lot of time so far. Because when you're working at a company, there may be lots of laptops for integration, and then you always start trying to find the environment variable. You're trying to find some editor, open it in Explorer, and it always are the same steps and just take time. So in that configuration editor, you just click right into it and modify the config. It's going to present it to you right there. So you don't even have to look up any variable. You just open Cyclone Insight and you have everything you need to go. Okay, so what's on the next slide? Yeah, there is the shapes demo feature I mentioned. So that is also a great way to learn about DDS. So basically what's about this, it's a well-known demo for DDS vendors. And yeah, you can create squares, you can create circles, you can create triangles, and then you can send them and receive it in like the same application or in another instance of it. Then you can say, it should rotate, should have different speed or size. And yeah, that's a great way to learn about quality of service. So you might wonder, why is there a tail? So when I send one message, so why is there a tail? And here in this example, we can see the history quality of service. So this is a history def, I think around 10 or something. And then the DDS framework keeps the 10 most recent messages in its reader cache. So that's why you will see a tail. And then you can play around. You can make it ready for late joiners, then you start and stop it, and get a feeling about it. So that's what I mentioned with download it, open it, and use it. So you just go in that burger menu, open the shapes demo, you send DDS messages. It's simple as that. Then let's go to the technology stack. So of course there are a lot more features, but I don't want to annoy you with all the theory here, and go quickly to the demo. Yeah, what technology stack is used? So in the backend, there is Python, and you might wonder about it. It's maybe more common for quick and dirty stuff. But in DDS, it turns out it's a real game changer. So we have this dynamic typing. So as I mentioned, in DDS, you have IDL files defining the data model, and in languages like C or C++, you have to compile these IDL files to have real types you can work with. But in Python, we can dynamically create or interpret DDS samples and don't need to compile anything. So that is why it's so smooth. We can just drag and drop IDL files in or use the type info from the network, and then we send and receive messages. And I think that's probably one of the top 3 features anyway. And that's why Python is such a good language for it, for this use case. Like when I imagine programming it in, let's say, C++, then yeah, we would need to ship a compiler and then try to compile the IDL files on the go or stuff like this. And yeah, with that, it's just that easy. And also CycloneDDS has a very good Python wrapper. Just can recommend it. So for the front end, I use PySide 6. So it's basically Qt for Python, and it's QML language. It has a declarative syntax, so you describe what you want, not how to do it. And yeah, that's a very modern way how to describe your graphic user interface. And Qt already had it like years before Apple had it in their Swift UI. So yeah, it's also involving getting better and better. It's just a great way and very quick way to do GUI frameworks. And yeah, the last point is you can have a native look and feel. So you may see that it kind of looks like a application on macOS, the native one. Just saw the screenshots. So the buttons are the same, the drop boxes are the same. And yeah, it just feels nicely and modern. So when you look at the dependency graph, you see, of course, CycloneDDS Python wrapper, you see Qt, then log guru for some log stuffs, and requests for the statistics. So let's have a look at the timeline. Let's go into history. So basically, I started this tool a year ago in my free time. And yeah, so, I'm working full time, and I developed it in like the 1 or 2 hours I have after work. So in April 24 was the first commit. Then 1 month later, the QoS mismatch was implemented. And even a month later, you could listen to DDS messages and import IDL files and all that stuff. Then it was a great start, and there was a little bit of a summer break. In September 24, you could configure all available QoSs. Then in October, you had the participant view. Then it took me some time for the next 2 features, showing the partition matching and send DDS messages. That was probably one of the biggest features, because you have to dynamically create the GUI from the topic you dynamically discover from the network. So lots of dynamic parts in there, which makes it quite complex, and yeah, you need to quite test it a while to have all bugs done. Then in March, the next feature, automatically discover domain, was added. And in April 25, I added the shapes demo. And yeah, then the so lovely statistics in May 25, so just a few months ago. And last but not least, the configuration editor. And yeah, July 25, we are right here today in the Eclipse community meetup. So you can see it's been quite a year, so there was a good amount of features came into it, and yeah, so today is the day to proudly introduce it to the community. Yeah, so what's what's on my mind? You know, it's open source. There are no product deadlines or whatever. It's just me thinking about what I maybe need in my daily life or what is fun. And yeah, I want to add a search bar for basically all lists, because sometimes this topic list is quite long and you maybe know where you want to go. So that would be quite important. Then to create writer from the network without IDL file. Basically, it's just doing, I think, all the things are right in place. It's just implementing it. Then, yeah, when you currently create a reader writer from the network, you have to select your QSs by yourself. And yeah, normally there's no need for it. Software could also just know it. So I want to use the QS directly from the endpoint, from the topic. And yeah, then graph overview. So what is that? Yeah, so that tackles the point that you want to have your runtime architecture view, and yeah, trying to find a way to put some nice little nodes and connections between them to have maybe not on all endpoints, but at least some partition and processes to get a great overview. And yeah, to have nightly builds. Yeah, currently there's only a build when a feature is added. So yeah, but you may want to use a newer CycloneDDS version because maybe some bug was fixed, and then you're gonna wait until there's the next feature. So nightly build will come pretty soon, I guess. Yeah, so that's what's on my mind. Let's go to the demo. So see if it actually works. I prepared a little setup. There's a little camera, there's a little robot, and there's a little station software. And as you see, there is this mark here and indicating something does not work. And we now want to figure out why does it not work. And yeah, that's one of the reasons for the tool. So let's check out. Just give me some moments here. Okay, then I will just start the station. So this is the station, I'm gonna call it. So we have here two video streams from a Raspberry Pi Zero streaming the video via DDS. We have a robot here. You can see the camera of the stream from the robot. And then the robot has some sensors on it. So there is sensor for time, speed, latitude, longitude, so basically the same sensor, and for temperature. And you can turn a infrared on and off. And as you see nothing. So it seems to be there are some bugs. What you're gonna do? Gonna try to look up in the log files. Oh, you can see here something matched. Okay, but yeah, that's difficult. So let's open Cyclone Insight. So it's just gonna order it a bit better. And yeah, we directly see, okay, something is wrong here. So there is a QS mismatch detected on that domain. And as we open it, we can see some tiled head controls, some sensors, some video stream, navigation, speed. So basically all that should be here, but there is nothing. So let's go to the temperature. And as you see here, the temperature is marked that there is a mismatch. We hover over it and we see, okay, durability and ownership is an issue. We could also just open it side by side to quickly have a look on it. Then we go to ownership, okay, exclusive, shared, that's the mismatch. So let me quickly fix it. So we can see here in the code, oh, it's exclusive and transient local, but it should be volatile and shared. So let's fix that very quickly and open it again. And oh, we see there is no temperature. So in my room, there is now 23 degrees and there is no QS mismatch anymore. So let's go to the next error. We have no video, but there is a video stream topic. And when you click on a topic, we see, okay, there are two writers probably writing the video stream, but no one's listened to it. But I'm pretty sure in my code that I listened to that topic. So what we're going to first thing do, we're just going to check maybe it's on a different domain. There are 233 domains. I don't want to go through them manually. So let's see if we can automatically discover one. So you can see the Cyclone logo is spinning here. And oh, there is something on domain 5. Our video stream. Okay, my readers just failed on the domain. So that should be a pretty easy fix. Just gonna close my program and go into the code and see, okay, that was wrong. I'm gonna fix it. And we're gonna see if there is some video stream. Okay, now there is something. So we can see here the night cam of the robot and surveillance video of that robot. And with the arrow keys, I can navigate the robot. So let's go quickly here and you can observe my guitars. That's great. And we can turn infrared on and off. So maybe you can see the slightly change here. And think you can, yeah. Okay, so when we go here, I can even show you the camera. So here is the camera. It's a little Raspberry Pi camera. Okay, so I think we made good progress, but still there is no latitude and longitude available. So maybe we try to look into it. So domain 5 is now clear. There's nothing more in domain 5. Let's go to navigation. So there is a reader and a writer. That should be fine. So let's have a look into the topic. What data is flowing there? So we just create a reader. We're gonna, yeah, you see there's a lot of QSs, but for now we just have to click on create reader because we're using default here. Then we jump to the listener tab and we see, okay, there is navigation data. There's latitude, longitude, altitude, but the status is false. When you click into it and the log stops, we can resume the log. Yeah, and it makes sense. The navigation sensor is right in my room. There is no GPS connection. It should be placed on the window to receive anything. But yeah, I want to show it to you. I want to test it, even when the possibility is not there right now. So let's create a mockup. Let's test it. So we see here I imported that IDL file. I think I can also show it to you. That is that navigation here. You have your insight here and you just go for it and then it's right there. So it's easy like never before. So let's click on it, create a writer. We just have to adjust the topic name here because it's just navigation and create a writer. Okay, so let's open the station again. And let's go to the tester tab. So now we can see here, okay, there is now the navigation data model. And yeah, we want to send now a valid position. So let's type in some random numbers, whatever, some altitude. And then we click write. And then we see, or shortly saw, the position. Of course, the sensor sends it periodically, so it's just there for a few seconds. But you know, you can see, okay, now there is latitude and longitude. So the feature itself works for displaying the latitude, longitude. It's just not that my system is ready enough. Okay, so now it seems to work pretty fine, everything. So what you're gonna say when a project manager come to you and say, hey, does DDS work good here or not? So you say maybe, yeah, all the feature work, guess it's fine. But you know, we want to have like diagrams and data to prove it. So we go to the statistics, and then we say, okay, I want to update interval from 3 seconds, show data last 2 minutes, and I want to aggregate it by, let's start with the host. So we can have an overview about the hosts. Maybe they're just like 10 or something, so we can quickly determine where to look next. So we go to host and start the statistics. Then the statistics are running. You can see first data is coming in. Let's just wait some seconds to have some more data. Okay, so we can already see, we can hover over it. Raspberry Pi 3 with the robot had the most retransmits. So it has about 10,000 bytes retransmitted. And yeah, it's always sending the video stream. So if the quality of the network would be bad, then it would go up. But it's just like pinned there at 10,000. So it indicates, hey, okay, that the network looks good. So nothing bad about that. So yeah, the Pi Zero also had the most topics. And yeah, my desktop PC with the station then, and the Pi Zero just forwards the video. So not that much. And yeah, so you wonder why does it has retransmits at all? Yeah, of course, because we have the discovery phase and it puts lots of network traffic initially onto it, and then you know things starting to retransmit, but that's totally normal. Yeah, DDS is based on UDP, so we will talk about 10,000 bytes. It's like nothing. I can already also show it to you. So I just restart my station here, and then we should see a bump for the Pi Zero and the Raspberry Pi 3. So let's close it, open it, going to Insight again. Okay, wait a few seconds. Okay, so now we can see, okay, the Pi 3 that just discovered someone and had some retransmit there. Okay, so we can scroll down, can make it a little bit bigger here. Okay, so there's retransmit bytes, there's retransmit count, there are the ACKs received, so that means data was successfully sent, basically. So we can see it's constantly moving up, so their data is flowing. And then there are the NUCs. So these are basically the requesting a retransmit. And yeah, of course there were some, so it makes totally sense. And we have the reliable readers also here. And yeah, we have like 150 for the Pi 3, we have 50 for Pi 0, and some for the station. Okay. Then, so that was basically to check the system's health. Now I can show you some other things. You can check for updates, or when you have to debug something, like if Insight has a bug, you can go here to the logs and check out the logs, change the log level and all that stuff. Then you also have the configuration editor I mentioned and the shapes demo. So let's have a quick look at the shapes demo, what it can do for you. So I already told you, so you can learn about DDS. So we have the shape lab, and yeah, we want to create maybe a square and want to have all of the colors. And it shall rotate a bit. And yeah, we're gonna publish that. So we want to have it reliable. All the squares shall gonna be received, and we're gonna publish it. So we can see now the squares with a white dot. Yeah, at this point I want to thank Hans from Zetascale. He helped bringing the most out of the shapes demo. And yeah, so now we can see we send something, but we want to receive them also in our application. Or let's do something crazy. We go receive it in another application. It's just a bit off script, but it's maybe a good idea. So we're going to open the shapes demo. We want to receive squares, going to subscribe to them. They are reliable. And we want to have a history, because we want to like to see the last 10. So we're going to subscribe them. And then you can see the squares with the black dot in the middle. That means that we are receiving these from the network. And yeah, so now you could play around with lots of QSs, and maybe you did something unexpected, then you would go to the Manage tab here and say, okay, that reader was not good. I'm gonna create one with, let's say, 25 history. So you can see now the history is much longer. And yeah, you just discovered that call your service. So as you saw, we found a lot of bugs in my robot setup here with the station. There's been quality of service mismatch. There was an application failure with putting it on a wrong domain. And we checked the health, so the statistics, and we can say our product manager, hey, thumbs up, that works. And yeah, that's basically my demonstration. And I hope you have a good feeling what you can do with it, and maybe how you start debugging it. Oh, let's go back to my slides. Time to see if it actually works. It worked. I would say pretty good for a demo. And yeah, so I'm at the end of the presentation, and yeah, I would ask you if you have any questions, and yeah, we can go from that.
Thank you so much, Sven, for this excellent presentation. And just a small reminder to everyone, again, if you have any more questions, please type them into the chat or ask a question tab. For now, I do see we have one question. Let me put it on the screen.
Ah.
There you go.
Is it possible
to see? Yes.
Yeah,
Please continue.
Okay. Yeah. Is it possible to see the content of the data types their fields and types. Yeah, not yet. Currently, you only see. I mean, you see, yeah. Just give me a second to see the data types. Yeah, you see the data, but not like the definition. So yeah, I think one goal is also to have a bit more detail in the listener tab. So maybe a bit more type information. But yeah, you basically see the values and the name of the structures currently. But yeah, you feel free to open on GitHub a feature request, and I'm looking into it basically.
Let me see if we have
Yeah.
any more questions. No. So this is it. Thank you so much, Sven, for this presentation, as I said before, and thank you to everyone for attending, and I wish you all a wonderful day ahead.
Yeah, thank you very much.
Bye-bye.
Bye-bye.